Hello, n times n times n plus n equal to 130. How do we solve this algebra question? We have n times n times n plus n equal to 130. N times n times n is n to the power of 3 plus n equal to 130. Now, let us transfer this guy to the left side. So we are going to have n to the power of 3 plus n minus 130 equal to 0. N to the power of 3 plus n minus, we can write 130 as 125 plus 5 equal to 0. N to the power of 3 plus n minus times 125, that is negative 125, minus times 5, that is negative 5, equal to 0. N to the power of 3 plus n minus 125 could be written as 5 to the power of 3 minus 5 equal to 0. Now, let us combine the common terms. This guy and this looks alike. So we have n to the power of 3 minus 5 to the power of 3 plus n minus 5 equal to 0. You will notice that we can isolate these guys. So we are going to have n to the power of 3 minus 5 to the power of 3 plus n minus 5 equal to 0. Nothing has changed. Let's proceed further. Recall that whenever we have a to the power of 3 minus b to the power of 3, this is simply the same thing as writing a minus b times a to the power of 2 plus ab plus b squared. Take note of this property. We are going to use it. By comparing this left hand side with this, you will observe that our a is n and our b is 5. So let us plug the values of a and b into this right hand side. We are going to have, what is a? A is n minus, what is b? B is 5 times, what is a? A is n. So we have n to the power of 2 plus ab, that will be n times 5, which is 5n, plus, what is b? B is 5. So we have 5 to the power of 2 plus these guys, n minus 5 equal to 0. What do you notice here? You will notice that we have n minus 5 here, likewise n minus 5 here. We can factor it out. So we are going to have n minus 5 into this guy, n to the power of 2 plus 5n plus, what is 5 squared? That is simply 25 plus 1 equal to 0, because n minus 5 times 1 will give us this guy back. Let's proceed further. N minus 5 times n to the power of 2 plus 5n plus 25 plus 1, that is 26, equal to 0. This implies that n minus 5 is equal to 0, or n to the power of 2 plus 5n plus 26 is equal to 0. Clearly, from here, n is equals to 5. This is the real solution. Let us solve this quadratic equation. N to the power of 2 plus 5n plus 26 equal to 0. You will notice that this equation is not factorizable. We can use quadratic formula to solve it. So our a is equals to 1, our b is equals to 5, which is the coefficient of n, and c is equals to 26. What does the quadratic formula say? It says n equal to minus b plus or minus square root of b to the power of 2 minus 4ac all over 2a. N equal to minus, what is b? B is 5 plus or minus square root of, what is b? B is 5, so that will be 5 to the power of 2 minus 4 times, what is a? A is 1 times, what is c? C is 26 all over 2 times 1, since a is 1. So let's proceed further. N equal to minus 5 plus or minus square root of 5 to the power of 2, that is 25, minus 4 times 1 times 26 is 104 all over 2. N equal to minus 5 plus or minus square root of 25 minus 104, that is negative 79, all over 2. N equal to minus 5 plus or minus. We can rewrite this guy as square root of 79 times square root of negative 1 all over 2. Let's continue. N equal to minus 5 plus or minus square root of 79. What is square root of negative 1? This is I from the complex number. So we have I all over 2. N equal to minus 5 plus or minus I times square root of 79. We just switch these guys. Nothing has changed. All over 2. This whole guy could be written as n equal to minus 5 over 2 plus or minus I times square root of 79 all over 2. This implies that n is equal to minus 5 over 2 plus I times square root of 79 over 2, or minus 5 over 2 minus I times square root of 79 over 2. Therefore, n1 is equal to 5, which is the real solution. n2 is equals to this guy, minus 5 over 2 plus I times square root of 79 over 2. And last but not the least, n3 equal to minus 5 over 2 minus I times square root of 79 over 2. These are all the required values of n for this algebra question. That's it. Thanks for watching.